All right, today we're going to talk about data exploration. We're going to grab our digital magnifying glass and our telescope and just dive right in. This is, hands down, the most important first step you can take when you're staring at a big pile of numbers, and it's what really separates confusion from clarity. So, let's get into it.
So, picture this. You've got a data set. Could be anything. Sales figures, results from a science experiment, survey answers, you name it. It's just sitting there on your screen, a spreadsheet just full of potential. But, now what? What do you actually do with it? Where do you even start?
Well, you start by exploring. There's a formal name for this, Exploratory Data Analysis, or just EDA. But really, all it means is getting to know your data. I mean, really know it. Before you can build any fancy models or make some huge prediction, you've got to understand the story the numbers are telling you. You're looking for patterns, trying to find anything that looks a little weird, and just kind of getting a feel for the landscape.
To help us on this adventure, Statistics gives us two incredibly powerful toolkits. First, you've got Descriptive Statistics, which is all about understanding the data you can see right in front of you. And second, there's Inferential Statistics, which helps us make predictions about the data we can't see. Think of these as the two must-have gadgets for any data explorer.
Let's stick with that gadget analogy, because it's a really good one. Descriptive statistics, that's your magnifying glass. It helps you zoom in on the data you have, right here, and summarize all its key features. Inferential statistics, on the other hand, well, that's your telescope. It lets you use a small, manageable piece of data to look way out into the distance and make really smart guesses or inferences about a much bigger universe of data.
Okay, so let's start by picking up that magnifying glass. We're going to focus first on descriptive statistics. This is the art of just clearly and simply describing what you can see in your dataset.
You know, when we're describing data, we're really just asking three basic questions. First, where's the middle? We call that the center, and we find it with things like the mean, median, and mode. Second, okay, but how spread out is everything? That's the spread, which we measure with stuff like range and standard deviation. And finally, what does it look like if I put it on a chart? And that's its shape, which gets into ideas like symmetry and skewness.
Here, let's look at a real example. This is a summary of the famous Irish flower dataset. It's a total classic in data science. Just look at how for each feature, like the length or width of a petal, this table gives us the mean, the median, and the mode. This one little table gives you an incredible snapshot of what a typical flower looks like in this data. So when we say center, what are we really talking about? The fancy term is measures of central tendency. And it sounds kind of complicated, but it's a really simple idea. It's just about finding one single middle value that does the best job of representing the whole group of numbers. The most common one, the one you for sure already know, is the mean. It's just the average. You add everything up and divide by how many things you have. It's simple, straightforward, and usually it's pretty darn effective. Next up, we've got the median. This one's easy too. You just line up all your numbers from smallest to biggest, and the median is the one sitting smack dab in the middle. Now, the cool thing about the median is that it isn't thrown off by super high or super low numbers. So if you have one extreme value, the median just ignores it, which makes it really, really useful. And last but not least, there's the mode. This is maybe the easiest of them all. It's just the value that shows up most often in your data, the most popular one. That's it. Okay, so here's a really crucial point. Knowing the center is great, but it's only half the story. Imagine two cities that have the exact same average temperature. One could have perfect, mild weather all year round. The other could have brutally hot summers and freezing winters. See? The average is the same, but your experience would be completely different. We have to measure that difference, that spread. And the best tool for measuring that spread is called standard deviation. All it tells you is, on average, how far each number is from the mean. So a high standard deviation means your data is all over the place, like that city with wild seasons. A low one means all the data points are huddled together, nice and close to the average, just like that city with mild weather.
Okay, so we've found the center, we've measured the spread. The third and final piece of our puzzle is the shape. What does our data actually look like when we plot it out? Sometimes data gives you that perfect, symmetrical bell curve you always see in textbooks. But honestly, a lot of the time, real-world data is skewed. It might have a long tail stretching out to the right with a few really high values. We call that a positive skew. Or it could have a long tail to the left with low values, and that's a negative skew. This is so important for things like income data, where a couple of billionaires can pull the average income way, way up.
All right, let's put the magnifying glass down for a minute. It's time to pick up our telescope. We're about to shift from describing what we have to making smart predictions about what we don't have. And that is the world of inferential statistics. The whole point of inferential statistics is to take a small, manageable sample of data and use it to draw conclusions about a much, much bigger group. This is exactly how pollsters can talk to a few thousand people and predict an entire national election. It's how a company can test a new soda flavor on 100 customers and guess how it'll sell to millions.
Now, the engine that powers all these predictions is a process called hypothesis testing. Sounds intimidating, I know, but the idea is actually simple. You start with a claim, an idea, like this new ad campaign will increase our sales. Then you collect a small amount of data, your sample, and you use statistics to figure out if there's enough evidence to believe your claim is true for everyone, not just for the small group you looked at.
Now, this is so important. Whenever you use a small sample to guess about a big population, you're never going to be 100% certain. It's just not possible. You're working with probabilities, which means there's always a chance, even if it's tiny, that your conclusion is wrong. And statisticians have names for these potential mistakes: Type 1 and Type 2 errors. A Type 1 error is a false positive. Think of a medical test that tells you have a disease, but you're actually perfectly healthy. Scary, right? A Type 2 error is a false negative. That's when the test says you're fine, but you're actually sick. Understanding the risk of each of these is absolutely fundamental to making good decisions.
So let's bring it all home. What's the big takeaway here? It's that these tools, this whole process, is how we go from a messy, confusing pile of numbers to making smart, confident decisions.
So, to recap, your Data Explorer's toolkit really has two main things in it. First, you've got that magnifying glass, which is descriptive statistics, to really get a handle on the data you have. Then, you pick up the telescope of inferential statistics to make smart guesses about the world you haven't measured. And when you put them together, that's how you turn raw numbers into a real story.
And that really leads us to the final question. Every single data set has a story buried inside it, just waiting for someone to find it. And with these tools, you can be that person. So, what story is your data waiting to tell?